make me productive with a C++ IDE. Now, I have my guess as to what the answer is going to be, but let's wait and see. Anastasia.
Yeah, thank you. That will be a live demo, so I do engage everyone come closer. You would be able to see more and actually better if you come closer. We have some spare tables here, so that's fine to move forward. There will be a live demo, fascinated. So what could possibly go wrong with a live demo? Nearly everything. So that should be fun to close our event. So yeah, I hope you had some nice dinner, got a grab actually a glass of wine or beer or something. So you should be in a good mood now to look at their C++ IDE. So let's start. C++ IDE. Not a very easy thing, as you probably got from my talk in the very beginning. So we put lots of effort into it. A funny story about CLion, actually, for a very long time, we actually didn't believe we could make it. Believe us or not, in JetBrains, we had concerns if we could make actually a C++ IDE. Then a fun thing happened to us. We started doing app code. Who knows what app code is? Okay, yeah, just some hands. So this is an IDE for iOS and Mac development. We started supporting their Objective-C and Objective-C++. And occasionally, we find ourselves in a situation when we do a C++ parser. We were a little bit surprised. We actually read in a nice blog post which was saying come on, you guess seems we're doing a C++ parser, so we're gonna start a C++ IDE soon. That happened, I guess, 2012. So 4 years ago, we actually released CLion, our cross-platform C and C++ IDE. We also, the same year, we released ReSharper C++, an extension for Visual Studio for C++. That's another story. I will be demoing CLion here. And C++ IDE, the main idea is to help you to be more productive with the C++ code. And that's all we try to implement here. So let's start with a very simple example here. What I love about CLion and about the productivity is when I see an IDE in front of me, I usually come on, can you generate code for me? Can you do that? I can sit here and you'll be writing code for me. Not as simple, but still possible. So let's generate some things. I have a few things here in the menu available. Let's start with the constructor. Okay, I will select all the fields. I will generate in place so that you don't have to switch between different files to see the result. So here's my constructor. Let me close this one so you see better. I can generate getters and setters. I will also do in place. I can generate equality operator. Why not? A few options here. I will turn them on. It will search if I maybe have some existing operator for this class, if I have it in some other place. Before, if I have, it will just add a missing operators for me. Okay, I'm even more lazy relational operator as well. Also searching for existing ones, just in case it actually needs to add one, not to generate from scratch. Can we do more? Stream output operator. I hate writing it manually. I think everyone hates, especially if you have a long class. Yeah, probably we can stop here. Let's look. I was lazy enough. All these things were generated automatically for my IDE for me. That's what I call proper productive laziness, when you just take a tool and it generates everything for you. Okay, let's make our life more complicated. Let's inherit from some class I have here. So I have this mammal class actually here, and it has a few virtual methods in it. Okay, what I can do now, let's do it here. We can override functions, select them all, and generate this stop. So here is the my make sound override and use self-energy override. Okay, make sound. I'm not sure I'm writing some reasonable code here. But just to show you an example, let's do some sound variable. And I have some actually fields in my class. Let's do some creepy expression. I'm not sure that it makes any sense what I'm writing here, but just to show you what I can do now. Like, I would like to generate more code. I actually can surround with whatever I want here. Like, for example, I will surround with if else close. So I put a line and I actually surround it quickly, and now I can put some condition here. I don't know if weight is more than 100, for example. What I can do in the other clause, let me call some function. You know what's the problem? I don't have this function. And that's a good thing in the JetBrains IDEs. When you don't have something, no worries. Just press Alt-Enter, and we'll create it for you. That easy. So just start using something, and then ask IDE actually, OK, I forgot to actually put a declaration on the definition list. Help me to define this something. And I can actually do that. So you actually see I just type a few lines of code, pressed a few shortcuts, and I got this huge amount of code. If you're ever measuring your results of the day by the lines of code, you know what's the optimal number of lines of code the developer could generate per day? You know? Anyone? Actually, some statistical number says like 70. So like half of them are already done. I'm nearly ready to go home, just in 5 minutes. OK, let's do some creepy stuff here. I have a few other functions inherited from my mammal class. I'm actually not that good in biology, not sure the hierarchy is correct from the biological point of view, but so. Let's do some interesting thing. I have this make sound function. Let's change the signature for this function. You know what? CLion will say, like, come on, you have a huge hierarchy using this function. Would you like me to update the whole hierarchy? Okay, yeah, why not? Let's do that. I will update. I will add some parameter here. Some ID probably. Let's refactor that. And now what we can see, here is my make sound in the human class. Here's my make sound in livestock. Here's my make sound in bird. And of course, my make sound in the parent mammal class. So when I agreed to update the whole hierarchy, what CLion actually did for me, it actually propagated my change to the top of the tree and then back down through all the branches. So if you want to refactor something which is deeply in your hierarchy, some leaf, it would be really nice and really productive if you don't have to update the whole tree by hand. It would be really nice if an IDE could like go through this tree by its own. And that's what we do. OK, done with this nice human example. Let's see what else we have here. What is the most important part of our code? You know? OK, different opinions. Documentation. Because without the documentation, no one will be able to maintain your code further, especially when you leave for a vacation or by chance leave a company. Documentation, like there are different ways to document your code. But documentation in CLion is much more powerful than just documentation, what you just like provide for function signatures. It actually tries to be smart. You probably remember some examples from my first talk. So because we built the whole AST for a code, we actually can show so many things about your C++ code. Let's start with the simple one. I have the documentation command. That's the Doxygen style, one of the most popular frameworks, popular tool to document your code, popular format. So I have my Doxygen command here, like some brief description and some per parameter description. If I call the quick documentation popup, I hope you see it. So I have all this information rendered in a single window. We do not call Doxygen in the background, don't worry. We render this on our own, just putting everything in place correctly. And you can navigate these classes at actually the link, so you can go through it and actually see through the whole hierarchy in the quick documentation pop-up. Do you like writing documentation in hands, all this documentation stuff? I don't either, so I prefer to generate like that. So 3 slashes, enter, and now the stop is generated. And the best thing, yes, I have my function signature here with some documentation, so I have some parameter. I will learn, add some description for my parameter. Then somewhere where I like, for example, put some definition if it's in a different file, I decided to rename the parameter. I said, OK, it will be called my value. Good thing, the documentation is updated automatically, so I like maybe after a year of change, the documentation will stay up to date. So I won't end up in some documentation naming parameters that are no longer in my code for maybe more than a year. Okay, so you can actually see and generate documentation. But as I said, quick documentation function is actually much more. And here comes the interesting thing. I actually showed it in my first talk, like macro replacement. Here it is. So the final replacement for my macro shown here. I told you about the boost macro, yeah? You remember that? Let's take some boost macro here. Yeah, here it is. It's actually much longer. Have you ever been interested in what's there behind the boost macro? Here it is. So you can actually see the final replacement. I know one person in the C++ community who is really excited about that. You know what he is doing? Boost HANA. Have you ever heard about that? Boost HANA is a huge and heavy meta-programming library. And the author, Louis Dion, is actually, he was debugging these macros in hands, just copying the output of the preprocessor and looking at them until he learned about our feature. He was so excited, he just forgot to ask me about all the other features. He just said like, yeah, finally, because Boost HANA macros are actually even longer than the one Boost macro I just shown to you. And it's like deeply nested, like maybe 20 or 30 levels inside. So okay, you can see the macro replacement, and as I promised, you can see the type inferred. So if I call here the quick documentation, let's make it smaller, you'll see the int value. You can guess if I'd call it for op1, what I get? Long, okay, naturally. And here, naturally the double. So you see we do infer these types on the fly, because we actually build the whole AST. We have like, we're crazy now, we have 2 parsers in CLion, and we build the whole AST tree, so we know exactly which type do you have for this variable. We know exactly what I actually calling, what is behind this macro. And this actually includes all the information we take from the compilation flags and environment variables, so we take all this into consideration when resolving the code. Just to demonstrate you that about the compilation flags. So I have this nice example here somehow. I have this code, and there is actually a preprocessor branch, and it depends on this special flag. What is this special flag? I have 2 CMake list files. One defines the configuration and have this special flag on, and it's 1, and other is defining the special flag, and it's 0. What I have here, so resolve context with flag comes me and brings me actually to this branch highlighted. Let me change it. So no flag, the proper branch will be immediately re-highlighted to me. So that means that the configuration we're using to resolve actually reflects this configuration with all the proper flags. So if, for example, you're doing some cross-platform development, cross-compilation, you're targeting several platforms. Naturally, you would expect the code sometimes to resolve to a proper platform to be able to fix it. So what do? You put this into separate configurations, then you just switch these configurations in resolve, and you got a proper branch highlighted for you. And that's very easy to read through this code and to understand what actually happens for this particular target, for this particular configuration. Like, I came from the embedded world. I was really lacking this feature when I was a developer. Okay, so that was about the documentation thing. Let's do some interesting stuff from code analysis. Like, okay, naturally, we're in JetBrains, so we do love static analysis. We have people who study static analysis in their university and who did like a PhD on static analysis. They're really cool on that. They can actually implement lots of interesting stuff. Code analysis in C++ was really fun. We did a lot of things. So first of all, we did our own analyzer, which can show you some different things, like redefinition of the name, for example, or like some other stuff, like function that hides a non-virtual function. Or, for example, if you're still a fan of the old-style printf, if you miss the format specifiers and the format specifiers in the actual string doesn't match the types, we'll tell you, come on, it doesn't match. Probably you will get some unpredictable result. Check that. And yeah, of course, using assignment in a condition I think every C++ and C programmer once in his or her life actually did that by mistake. I could blame myself, I did more than once. So yeah, we highlight these things saying like, probably that's not what you actually meant here. And a very nice thing, escaping from the local scope, a very popular error in C++ world. So when you have some local variable and then like, okay, I will return this value using the address, and it's no longer valid. So that's a runtime error. So yeah, you can check it as well. We do work, as I said, with 2 language engines. So we have our own language engine, and the second one was introduced a year ago, and it works in Perl, and it's based on Clang. It's our own branch of Clang LLVM repository with a bunch of different fixes on top of Clang. And what we do here is, first of all, our engine actually provides an error, like no matching function. So the overload resolution failed here. But then we ask Clang for a particular reason for that. And it provides this error like substitution failed because no type named inner type. And you know what I can do? I can navigate. So I can actually look at what actually was causing the failure, where they actually found this inner type requirement. Like the same here, it will say that no member named method. And I can also navigate to this place and see where it actually been. So here is it in just one file, but you can guess it could be in different files, and you'll navigate to a proper place. So as I said in my first talk, if you're debugging the overload resolution that failed, you can actually get some additional information from your tooling. Okay, pretty exciting example I really like. We have C-style casts, which you can actually configure in CLion and say like, okay, come on, I'm old style, I'm legacy, I will use C-style casts. But you can also say like, I will be more modern, I will use C++ style cast. What's the problem with them? There are more than one. So you actually have to select which cast to use if it's a C++ cast. We actually made your task a little bit easier. So when the type doesn't match, if you press Alt-Enter and ask to cast, here's the static cast, dynamic cast, reinterpret cast, and const cast. What we try to do, we try actually to understand from the context which particular cast you actually need and try to add it for you. Naturally, you can say like, you can't always do that. Yeah, we can't, but we try to do our best, and in like, as you know, like this law of 80 to 20, like in 80% of the cases we're matching the cast properly. So you might be quite happy with that. When we started doing code analysis, we found out that we have one person in the team who actually did a nice PhD on data flow analysis. We couldn't escape from that. We asked him to implement a data flow analysis for C++. That's the thing that the compiler can do for you, and that's the thing that helps you with the runtime issues. You know what? Because it analyzes how the data flows through your code and suggests you some particular like flaw in logic, some issues. So for example, here it says me like the condition is always true. You can guess that there is a previous if-else clause where I'm either assigning red or it's already yellow. No need to check that, like in this case. So that's true already. Okay, another example of that kind is here. I see the unreachable code. Why so? Because that's the case for the color yellow. And in the previous switch case, I am actually assigning red, blue, or green. The compiler can't get it because it doesn't take the data, how it flows through your code. It doesn't do that. It doesn't need that, actually. That's fine. That's what you expect from the compiler. Who would expect it actually analyzing your data? Probably not your security department. So, like we do that. From one point, I really love these checks. From the other side, that's the first check I usually recommend to turn off when there is some slowness, because you can expect that data flow analysis is not that quick. It analyzes the whole data. So yeah, it's cool. You can actually run it on CI server. Like we have this inspect SSH script. So when you install a CLion, so you can run all this code analysis just on a CI server. For example, you can run the data flow. Okay, when we did a few code analysis checks, we found out that there is a nice Clang tidy analyzer, which is done by the LLVM community. It's a part of the LLVM infrastructure. So let's see if we have some nice example here. Yeah, so what we did actually, we bundled the Clang tidy into CLion. So when you get some checks from CLion, they're marked like CLion check, and you can get them the same way as you get the CLion's own code analysis checks, and there are the quick fixes taken from CLion. Like here is the modernized groups, so I can, for example, convert lambda to std bind, or like here it suggests me to use range-based for. I can do that as well, and like pass by value and use std move. Why not? Like, to be honest, our own checks, they're like 60 or 70. CLion from LVM 8.0, the recent release, which we bundles, is 330 checks. Not all of them are reasonable, so we try to keep the default configuration like a little bit limited, so we don't turn them on by default, because there are dozens of checks. Like, some are created by Google, some are created by other companies, that some particular checks they need. You probably don't. You can tune the configuration in the code inspections. You can like actually select which profile for a CLion you would like to get. You can check them here in the list, or you can just provide the CLion file in your project and we'll read the configuration from it. You know what's the best thing about the CLion? That's an open source linter, which you can extend easily. Guess you have a specific check for a team. No IDE will implement it for you, because it's very specific to your project, but you want it. You want your team to get it in the IDE and to force them to fix it. What you can do, you can implement and check on top of CLion. That's very easy. There are dozens of examples across the internet, a huge documentation. So you just get this AST built by the CLion and do a check, and then you can actually specify the CLion executable in CLion and use your custom CLion executable, and that means that you'll get all your checks the same way in the IDE as you get, as you see them like currently. So that's a good thing. That's always good to know that you can actually extend the thing. And of course, when we learned that we can extend the CLion IDE, what we actually did is decided why not to implement a couple of our own checks just to see how it works. We did that. We took one very, let me take the example, one very interesting check that we call argument selection defects. The interesting story is there is a huge scientific paper behind that check. So what it does, I have a function called getUser here, and it gets company ID and user ID. And I did one mistake. The order of the parameters was wrong here. So I passed user ID and then company ID, but they're the same type. So the compiler will just miss it. It's fine to compile this code, and I might miss that as well. So there is a paper written by Google people who actually implemented some heuristic algorithm, how you can actually detect that the order is wrong based on the name of the arguments and the parameters. So if you are like good enough in naming your parameters, if the names are reasonable, if you just don't name your parameters like blah, 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 then probably it will guess nicely like if you miss the order. So definitely we turn it off for all the short names like X, Y, Z, and we turn it off for all the functions called like swap, because naturally doing a swap means you're swapping the arguments. That's fine. So this paper actually takes all these things into account, and they implemented that. And of course you can call a quick fix and it will switch it in all the usages where it's the order is missing. So yeah, we did a few checks like that, and the other check that I probably can show you here. Do you know why it suggests me to rename? I will tell you, because I have a naming convention configured for my project. So if we go to code style settings, you'll find this nice UI. It will get even bigger and more flexible in the next version. We'll get more options here. So, but the idea is that it's much easier to read your code if the naming conversion is proper. So if the whole team is following the same naming conversion, then a new person entering the team could easily guess by the code, like if it's a function, or if it's a class, if it's a private method, or maybe it's a public function, if it's like a macro, if it's a enum, so whatever. So to read the code when you have a naming convention is a very easy thing. So we do support it, so you can see the list of entity kinds here on the left, and you can configure custom prefix, custom suffix, and you can select the proper style. And you can actually set from a known, known conversion that we have predefined for you here, like Google and LLVM. They all have some predefined naming convention. So yeah, and this check actually tells me that the name is not correct. It doesn't follow the convention. So and then naturally can do a quick fix with renaming and will update all the usages. So yeah, it's a good thing actually to force your team to use. And naturally you can configure it and share the settings in the version control so that the whole team stays on the same level of the configuration. Okay, that was code analysis. Enough for it. Let's do something more exciting. What could be more exciting than refactorings in C++? I have a function here called person. What I will do, I will change the signature. And changing the signature, I will do another parameter. At the same time, you can see the completion here. I will call it, not a very good name, don't use this naming conversion, calling the parameter P1. But I will do just for a demo. So you see what I have actually. I have the usage of the call person function, and I was substituted a default value just to keep my code still compilable. You now can find usages of this function and actually change the value you actually need in all these places. But at least by default, you have some nice value. And if I do the change signature again and swap the order, if I still have the wrong order, it might be not good because I have null ptr there. Probably something will go wrong for me. Let's hope for the best. And oh yeah, we had them swapped. Cool, I'm safe. So that's why I like the automatic refactorings with the IDE, because they keep me safe. I was showing you already the hierarchies. Yeah, let's extract something. Let's close this to show you more. I have this function extract example, and it's actually called here. I have a few things to extract. I will first of all extract this value. You see we have lots of extracts here, whatever you want to extract from your C++ code. I'll extract a parameter. Nice thing, it asks me actually, I see 10 occurrences of this value. Do you want me to extract all of them? Of course I do. I think they're not just occasionally. Let's do that. I will call it D for something. I can declare a const if I want. Here I have my parameter. Let's come back to the usage. Oh yeah, here is my value. Cool. Let's extract something more. Let's extract this expression, the whole expression to the variable. Extract variable. Oh, again, more than one occurrence. Okay, let's check them. You see them highlighted. You see that the expression was actually more complicated. It managed to extract the part of it. Okay, so I will extract these occurrences. They will be substituted. Everything is fine. So I can extract type def. I can extract define. I can naturally extract functions. So all these things are possible. And yeah, one last thing about the refactoring. Have you ever dealt with pulling members up and down through the hierarchy? So I will show you, because probably not everyone sees that. There is pull members up and down. And when you call it, that's fantastic. Now it's not only asks me where to pull my method for this hierarchy, but it also highlights me some things from my class in red, saying that probably it's used by the method you're going pull up. You will need that, so you'll have actually to to select them all and to pull them up and down for a hierarchy. So yeah, you can actually do that. Okay, refactoring was nice. Resolve context, we also got it. Let's do some nice debugging demo. Yeah, I guess the regular debugging demo would be now fun. We'll do some cool debugging demo. For that, I will need my Linux machine. It's a virtual machine running here on my Mac. Yeah, so you can actually guess. Sorry. Yeah, Linux enough. Yeah, so that's a Linux machine running here on Parallels on my Mac. What I want to do, there is a nice and magic word, remote debug, which actually helps us to debug and develop when we're not on a target machine, because in most cases we're not. We're using the machine that our company gave us, or the machine we prefer, or just the machine which is convenient because we, for example, have everything here installed, but we develop for another platform, embedded platform, or just other architecture, or just other target platform, or maybe it's just not possible to debug on your local machine due to some reasons. So we have two types of remote configurations. So first of all, there is a case when you just want to debug on a remote machine. So you're working locally, your code is local, you do all the things here, but then you have some different architecture where you want to debug. For that things, we suggest you to use GDB server remote debug configuration. It's very straightforward, very simple. If you go to edit configurations, let me find it, here it is. It's called GDB remote debug, obvious name for that configuration type. So what I actually provided here, the name, that's simple enough, GDB. So you can switch it, but like by default, we bundle the GDB built for multiple architectures already. So we don't just bundle the GDB for the particular architecture for like this binary for my Mac. I have this binary for CLion when I was installed, but it has the GDB built for multiple architectures already. You still can switch it if you have some very specific platform for which you actually got your GDB compiled from GDB utils. So, but in most cases, you will be fine with the bundled version. So I provided the like whatever the connection I will be using, the address, the port. Symbol file, what's that? For debug, you naturally need some debug symbols. Where to take them? The easiest way is just to take the binary which you will be running and debugging actually there. If it's built with the debug flags, it has the debug symbols. Okay, so I will just copy this binary to my local machine and provide it here for the symbol file. And the last thing is path mappings. For CLion to understand the breakpoints I will be setting in my editor and showing me all the things in my code, it actually needs to understand how my local paths are mapped to the paths on the remote machine where I build the actual binary. If I build it locally for that architecture, that's fine, that's the same paths, you don't need the path mappings. But if, for example, it was built on some, I don't know, CI server with a different architecture, probably the paths to the sources were different, and the debug symbols will be using this direct path to the sources, so we have to know the mapping. So okay, we successfully provided all these things. Now all we have to do is to go to my virtual machine to start the GDB server. So it just starts the GDB server for localhost, which is my Linux, port 8080, and my binary, and it's now listening on the port. I will go now to the remote app, and I will call the debug. The debugger in CLion is connected to my remote machine, to my Linux. And now it actually stopped on a breakpoint I have. What I can do now, I can do some stepping here. So here is my editor on my Mac. I do some stepping. You know what these things is? We call it inline variables view, a very cool thing. My favorite feature in debugger. When you debug, you can see the actual values of the variables right in the editor. So just don't need to switch or to hover to something, just see them. And the good thing is that if I select the variable here, I will change the value to 300s. You'll see it's a little bit colored in orange to show me that I actually updated it, and you can see the updated value. Yeah, and you can go forward and step through the things. You can evaluate expressions here, run to cursor, do all that kind of stepping, and actually debug your application. And this whole application, if I stop it here, probably will see there, yeah, that's some crazy game running here on my Linux. I was debugging that game. Okay, so I'll stop it here. Sometimes it's not enough to deal with the remote debug. Sometimes I need something more complicated, the whole cycle of remote development, which means I have my local machine, but I have to compile and run and debug my code on some other remote machine, like Docker or some other architecture, whatever. You can do that. How it works right now in CLion. So we actually build the configuration where we take the local sources and synchronize them to the remote machine using CLion, and then we synchronize back the header search paths. I will show you why in a couple of minutes we do this last synchronization. So first of all, what do you have to configure? Nice question, actually. So all you need is a toolchain, remote toolchain, naturally. It will go to the same Linux host. I have some credentials to this machine provided here, and it now tries to connect to my remote machine and to ask if it actually has all the tools I need, like the make, the C and C++ compiler. Okay, it detected all the tools, I have them. Now, remote GDB debug, we implemented in a general way. It works for any project model supported. You probably know we're not a little bit more than CMake right now. We have Gradle for C++ and compilation database. So remote GDB debug works for all three. Full remote mode for now works only for CMake. So that's why I need to provide a CMake profile. So I'll do that. That's just a remote profile using my remote toolchain. That's it. Cool. What we can do now? First of all, let's run it. So it's remote run. Let's switch the configuration to show you in details. Where it was, yeah, here. So first of all, my debug configuration is local configuration. So that just the application simply prints the sys name. So let's run it. Since I'm running locally, it says me Darwin. I said, okay, let's now switch to remote toolchain. Now let's run. Oh, cool, I got Linux. That's actually the name of my remote machine. So what actually happened there in the background, it actually connected to my remote machine, compiled the code there, like run it, and provided the output here. You can debug the same way, in the remote way, here. And also the thing that I like is, again, about the preprocessor branches. You see that here the Linux is actually highlighted, because I'm using the remote configuration. If we switch to the local configuration, oh, cool, naturally, the Mac branch will be highlighted. That's what I expect from my tool, to highlight me the proper branch. If I'm working with a remote machine, yeah, cool, I will be, like, the Linux branch will be highlighted to me. So that's the remote debug and the remote development mode. Now, just a few words about the integration, like IDE, you know what it stands for? Integrated Development Environment. That means that's the whole environment. That's not just about the code. So what we have, so like that's a regular IntelliJ-based IDE. So you can guess we have all the version control support and all this stuff. Not that exciting. Let's do some exciting stuff. Like, who actually uses the Valgrind? Anyone? Cool, yeah, you're my favorites. I like this tool very much. So we actually integrated the Valgrind memory check. So that's a nice thing to catch the memory leaks in your program. So what you can do, you can run the application with Valgrind memory check. Yeah, so that's, I'm not gonna run it on remote. I don't have it there, run it locally. Yeah, so it actually gets you to this nice output here, sorry, this Valgrind tab, and what you can see here is just the whole stack trace of all the leaks. The good thing, why I actually recommend you to run the integrated tools from actual IDE, not separately. I can run my application on the Valgrind separately from terminal. What I would miss actually is the actual navigation to my code in my editor, because here I actually have the piece of code, I can jump to the source code in the editor, so I can go and fix the problem immediately, just from this trace. That's Valgrind, but there is another tool in the community, very popular for checking all possible kinds of address errors, and not only, that's Sanitizers. Sanitizers are a bit different from Valgrind. Like Valgrind, that's just a tool which you run your application under Valgrind. With Sanitizers, you have to recompile your code. So it's implemented, the functionality is implemented in a little bit different way. So if we detect the -f sanitize flag in your compile options, but we know that you're probably using some sanitizers, cool. If you simply run your application, there will be a tab with sanitizers output. And just the same, you can go through the stack trace and you can navigate to the source code. And the good thing about the sanitizers is that you probably know there are so many of them. Like there's address sanitizers, memory sanitizer, leak sanitizer, threat sanitizer, undefined behavior sanitizer finally. So yeah, some drawbacks, like it's only supported for some Clang version and some newer GCC versions starting from version 5. Both Valgrind and Sanitizers are not working on Windows. These tools do not like Windows platform. Sorry for Windows users. So yeah, but still it's good actually to check them, and you can provide some settings here. Okay. What else actually left from the dynamic analysis? Valgrind, Sanitizers, what else? Yeah, anyone? Profiler. So if you need to profile your code, and if you're lucky enough not to be on Windows, sorry, we don't have Profiler for Windows for now. So we have it on Linux and Mac. On Linux, we're using perf. On Mac, we're using DTrace. And so I actually can profile my application here. It will start the profiler. It tells me that the profiler is attached. I'm waiting for my several-threaded application. Now I can open the profiler. I can look at the flame chart for all the threads or some particular thread. I can go to a call tree. I could go to method leads. And actually, again, I can jump to source. So if you got the profiler output, it's actually linked to the source code. So just profile your code, file the problem, and then go to your code and fix it. That easy. Static analysis, dynamic analysis. What else we do miss to write a perfect C++ code? I hope you do that. I asked that in the very beginning. There were just not that many hands who are not doing unit tests. Unit tests, naturally. CLion has integration with Google Test, Boost.Test, and Catch. I love Catch, not because the Phil Nash, who is the author, is our developer advocate, but because that's a nice framework, actually. It's header only. So despite Google Test, which you actually have to link with the whole library, you can actually just include Catch header file, and you're done. So I have some tests here. So when you see these nice gather icons, they're actually showing me the state of the test from my previous run. So some tests actually succeeded, some tests failed, but also this is a run icon. So I can just do, OK, run the test for me, and I'll get this nice built-in test, the unit test window with a test runner output, so I can investigate the tests, I can export results, I can compare with what I got previously here. So yeah, I can do all these kind of things. The Boost tests the same, so just the unit test, which I actually also can run. If you ask me which is my favorite feature for the unit test integration, I will tell you just one which I really love. It's called rerun all the tests that actually failed. And a very direct case where this is very useful. Imagine you have 200 of unit tests, half of them failed. You have to fix them because before that, you're team lead or someone says, no, don't commit this code, all the tests are failing. You have to fix them, so what you do is just you constantly rerunning the tests that fail, trying to fix the code until it goes to 0, and then you just check the whole bunch from scratch just to be sure that you haven't broken anything again. So that's a very nice workflow, so just rerunning the tasks and just saying OK, just rerun all the tests that fail. I don't need to select them manually. That's actually quite convenient. So yeah, that's the unit tests, and yeah, probably that's mostly it from the exciting part. Yeah, so just one word about the CMake thing. So as I said, we're not only about the CMake these days, so we have support for a compilation database and Gradle C++, but CMake still is a first-class citizen for CLion, so we treat it as a language. So if you start typing in CMake files, you'll see the code completion, and actually all these things, all these file names, these are the actual links to the file, so I can actually go to them using the usual go to declaration shortcut. And there are live templates, so if you've heard about the live templates in the IntelliJ platform, this is just the template you can configure, put some piece of code you use most often, and then call it with some short combination of letters. You can provide live templates for CMake as well, we have some for Google Test and Boost, and that's easy. So yeah, and just you can do all the things like CMake install, it will be supported, and it will appear here in the build tool window. So that's why I call CMake support the first-class citizen. But just again, it's not about the CMake nowadays. There's compilation database, which I treat as a nice workaround for makefiles. If you do the makefiles and we still don't support them naturally, you can do for the compilation database. We have a whole tutorial on our help how to do that. So go on and try. So that's mostly it. So I hope you enjoyed the demo. It waked you up a little bit. Yeah, and I think now we'll have some nice ruffle and closing words. I think you were waiting for that, yeah?